Hello everybody, welcome back. Now this is the part 2 of designing a serverless architecture for National Fuel application. Now if you haven't watched the previous episode, you can find the link in the description and we are going to continue from where we left off. Just to recap what we have discussed in the previous video, we discussed the user registration architecture and we were developing a serverless architecture for an existing real-world application which is called Fuel Plus, where the users are able to receive an QR code after registration and they can use that QR code to get their fuel. So in the previous episode, we discussed about registration of the personal details, and this application is passwordless authentication, meaning we'll be using OTP or one-time password. So users will receive a code to their mobile application and thereby they will log in to the application. So we discuss how this verification process happens, and after verification process, users will add their details like first name, last name, address, and then they will click next, and those information will be saved in a DynamoDB table. So the requirement wise, these are the functional requirements. We discussed how a user is able to register and log in with OTP, and how can users store their personal information and vehicle information. So these three functional requirements we already discussed. So now we need to discuss about the vehicle registration part of it. That is the second step of the registration process. So once the users are successfully registered, then they have to register their vehicle. In the vehicle registration process, the application has to connect to a external system. This is the RMV system or the Department of Motor Traffic System, to verify the information that the users have added is accurate. So if we go to the UI part of it, users will add their vehicle number, vehicle type, the chassis number, the fuel type, and then they click register. So then it will connect to the external RMV system. If the information is accurate, then the user registration will be successful. Now in the previous episode, we discussed about the user registration part of this application. Now this is the proposed serverless architecture we discussed in detail in the previous episode. And today we are going to discuss about the vehicle registration architecture. Now by the looks of it, it has lots of connected services. But I'm going to discuss each and every one of it and the reason as to why I use it in this manner. Like I already mentioned, there's nothing called the perfect architecture. That all depends on the business requirements. So in this episode, let's discuss if this serverless architecture can justify the business requirements. Let me come quickly to the UI one more time. So the user will fill this detail and click register. So when they click register, there will be a HTTP request. And as we mentioned, we are using CloudFront as the first point of contact. And the CloudFront will have a behavior or the path that will be pointing that traffic to an origin, and in this case we'll be using an API gateway origin. Now API gateway is the managed REST API service from AWS, and it will receive this post request. Now this could be HTTP post request with the details of the vehicle registration and the user detail, and once it get to the API gateway, the request will be authorized. Now in the user registration flow, I already discussed how API gateway can be connected with Amazon Cognito user pool to verify the token of the connected user and making sure this request is an authentic one. So similarly, even though I haven't added it into the diagram, the request will be first authorized. And after it is authorized, then we are using another managed service. In this case, we'll be using EventBridge. Now, EventBridge is the serverless event bus service from AWS. So with EventBridge, we can create our custom event bus and then we can start publishing events to the event bus. Now, since this is a managed service, the built-in scalability is there, and it can ingest real-time events from the producers. Now this acts as a pub sub system, that is, there's a producer and we can have multiple subscribers that have subscribed to these events. Now this EventBridge service is pretty much similar to SNS. Now SNS is the simple notification service. So this is also act as a pub sub service. We can publish events to SNS and then we can have multiple subscribers listening to these events. The difference between SNS and EventBridge is that EventBridge has content-based filtering. That means it can look at all the attributes of an event: event body, event headers, metadata, and so on and so forth. So it can access all the details of an event. Now, essentially, these events are JSON objects, and then create filtering rules that will route that traffic to the intended targets. Now, in this case, I'm creating a SQS queue. Now, this is a managed queue service from AWS. We call it simple queue service, and this is a highly scalable queue. It can ingest millions of messages and store this message temporarily as well. So this acts as a transient storage. It can retain message up to 14 days. I think the 14 is the maximum number of days, and the default is 4 days, I believe. So even your downstream services are offline, SQS queue can ingest events or the messages from upstream services. So here, view connected SQS queue as a target for EventBridge. And we create an event rule. So event rule is basically we will say what type of events should we route to this SQS queue. So when you are writing an event rule, we can access to the entire body of the event, including the headers and metadata. So here we will write an rule: if the event is vehicle registered type, then route all those events or the messages to SQS queue. So when users hit that register button, there will be a post HTTP request with all the information in the post body, and that will be received by the API gateway. And we have directly connect EventBridge to API gateway through service integration. Now, usually API gateway is connected with a Lambda function, but here we don't need that Lambda functions because we can directly connect to EventBridge, and that will remove the Lambda functions altogether, and we will save some cost. Because if we are using a Lambda function, it will only use AWS SDK and call SDK method to put event into EventBridge. We don't really need that. In this case, the Lambda is used as a transport mechanism. For usually, if you use Lambda for transporting, then probably you can take it out. However, if you want to transform the request before you send it to the downstream service, then Lambda is ideal. But this is just transporting, so we can take it out altogether because there's a direct service integration from API gateway to EventBridge. And that will save you cost as well. So you don't have to bear that Lambda cost, execution cost, as well as the latency, because you don't have to bear any Lambda call start delays as well. So from API gateway, we will create an event directly in EventBridge, and we'll call it this is vehicle registered event, and then we'll write an event rule to look at these event registered messages and then route it to SQS queue. So EventBridge will directly queue those messages, so we call it enqueue these messages into SQS queue. And this is how we connected these three managed services. But now let's take one step back and see why I suggest this type of an architecture for our application and what we are trying to achieve from this. So first and foremost, why did we use an event bridge here? Nowadays, in most of the serverless architectures, we tend to use EventBridge. One of the reasons is that EventBridge make it very easy to extend the functionalities of your application. For example, I've heard that they're introducing another feature to register these corporate vehicles, because one company can have multiple vehicles and they are planning to add that functionality to the application. So in that case, we can ingest those events also into EventBridge. And in the event body itself, there will be some identifier, maybe let's say the type corporate. Then we can easily write another event rule, and that event rule will only filter those corporate events, and then we can send it to whatever the target we want. Now let's imagine the corporate events are being differently processed and there'll be a different external system. So in that case, we can filter those events and then route them to that external system. So it's very easy to extend our application, giving more focus on extending the current application architecture. Okay, so why did we use SQSQ here? Can't we just have a Lambda function, maybe this external API calling Lambda function, directly receive messages from EventBridge? Now I'm using messages and event interchangeably. Usually events are JSON messages, so don't get confused. We can of course send these events to a Lambda target, and then this Lambda can send all these requests to the backend or the downstream service, in this case the RMV system, and do the verification process. But imagine we will receive thousands of vehicle registration requests concurrently. So when you are designing serverless system, we have to prioritize on concurrent requests, not the number of requests. Number of requests can be handled one way or another, but handling the concurrency is the challenge. So if we have 1000 concurrent requests, then EventBridge will invoke 1000 Lambda functions in parallel. Then this RMV system, whatever the third-party system, will receive all these requests. So it will receive massive number of requests at once. And this third-party system, we don't know how scalable they are. And if you are not designed for scalability, then these systems will surely fail. So we wanted to stop that. So how can we stop? The easiest way is to introduce a queue. So once we have a queue, the queue can ingest all this traffic, but the workers who will consume the queue or who will dequeue the queue can be controlled, because this part, the left side part is at our control. This RMV system, the third party system, we don't have any control. So we can control whatever at our end. Now here, in order to control the number of requests we are sending to the downstream service, I set the batch size to 1. Now here we connect SQS and Lambda using event source mapping, meaning that there will be the Lambda service, the managed Lambda service. It will poll the messages from SQS queue and send it to these Lambda functions. So we can set the batch size up to, I think, 10, and here I set it as 1. So the Lambda function will receive just one message at a time. But then again, how it goes is, when one Lambda function receives one message, and if there are more messages in the queue, the Lambda will start to scale. At first, it will scale up to 5 Lambda functions, and then it will start consuming one message each. And if there are more messages, it will keep on scaling. So here also, even if we set the batch size to 1, we have to manage the concurrency of this Lambda function execution as well. Now in the previous episode, I discussed about reserved concurrency, and here also we can define a reserved concurrency for this external API calling Lambda function, so that we will control that concurrency of this Lambda function as well. For example, if we set this concurrency to 5, at most, there will be only 5 of these Lambda functions executing in parallel. And we can adjust this batch size and also the reserved concurrency depending upon how capable is our third-party system. So in this case, this is just an assumption to set the batch size to 1 and the reserved concurrency to 5. Now one might wonder, hey, if we control this executing part of this Lambda function, there will be a lot of messages in flight. In flight as in, there will be a lot of messages in the queue. So those users will not be served immediately. Is that correct? Yes, that's correct. That's why in the requirements, I particularly mention users should receive an SMS once the QR code is ready. So we will remove that synchronous call to receive the QR code as soon as they click register. Instead of that, we'll be using an asynchronous flow. So as soon as users click that registration button, this button, the call will be received by the API gateway, and the API gateway will add that event or put that event to EventBridge, and then EventBridge will send a message, okay, API gateway, I receive your message. And that response will be sent to the front end. And from the front end, we can show a message to the user, okay, your data is being processed. You will be notified once the processing is complete, and we will send you an SMS. So users really don't have to wait to get their QR code immediately, but they will know, okay, they will eventually receive an SMS, and that SMS will have a link to get their QR code. So when we are designing scalable system, this type of asynchronous event-driven architectures are really helpful to make these systems very scalable. So now let's discuss when this external API calling Lambda sends a request to this external system with the request information like the vehicle details and the user detail, and the external system, in this case the RMV system, will check against their database. If the information is accurate, they will send, okay, this is a legitimate request. This is a legitimate user and his vehicle information. So at that time, this Lambda will put another event into the event bridge. And we can call this event maybe event matched. And this event will have a body of JSON, and that will include whether this is successful or unsuccessful. And this event will also be added to the event bridge. And we can write another rule listening to these type of events, event matched type of events. And then that will be routed to a step functions express workflow. I'll discuss in detail as to why we take this decision. But before that, let's discuss a failure situation. Now, although we try to control our traffic to the backend system or the external system, sometimes this system can be offline. So in that case, the Lambda will try to connect and it cannot. It will try a few times. And if it is not successful, then the message will go back to the queue. Now we can define a DL queue or dead letter queue to our SQS queue. So dead letter queue is nothing but another SQS queue which we can attach to the original SQS queue. So in this configuration, we can say if a message is being received by this many times, then send it to a DL queue. Now here I have set the receive count or how many times this message has returned to the queue to 3, and the return count of this message is 3, then it will be added to a DL queue. Then we can again attach a Lambda function that will consume the message from the DL queue, and I call this notify failure Lambda. So what it does is it will send an SMS to the user. The vehicle registration process is not successful, and they will receive an SMS once the vehicle registration system is back online. So they know something has gone wrong, and they will wait until they will receive an SMS from the system. So now let's talk about this section of the architecture. So what is this section? You will get a message from the external system whether the information is valid or invalid, and there'll be a rule listening into that type of events, and it will invoke a step function express workflow. So what really is a step function? So step functions are a managed service from AWS that will help you to manage your workflows. So in our case, our workflow would be whenever we receive some confirmation from the external system, we should check whether the information is valid. If they are not valid, they have to notify the users the detail that you have entered is invalid. Please try again. If that is valid, we will skip this step and we'll get to the register vehicle step. In this case, we will add the registration information into maybe a vehicle table. So this is a DynamoDB table. So here we will store the vehicle number, vehicle type, and these details in this particular table. And after that, we need to generate a QR code for the user. And this Lambda function will take care of it. It will create the QR code, and it will also create the QR code image and add it to an S3 bucket. And we'll call this S3 bucket QR image bucket. And after that, the same Lambda function will get the S3 URL of that QR code and add that URL to the user table. So our user table will include user details, first name, last name, address, as well as QR code image link. And that will store a link to the S3 image. So as you can see, there's a set of things that we need to execute in a certain sequence. Now we can use AWS step function to orchestrate these workflows. So as part of the orchestration, it will invoke the correct Lambda function by looking at the input data information. In this case, from our event rule, we will receive whether the user information and the vehicle information is matching or not. So depending upon that Boolean value, we will invoke this Lambda function. If not, we'll skip that. We'll start or the AWS step function will invoke register vehicle Lambda. And once this is added to the vehicle table, it will invoke the other Lambda. So what if this Lambda failed to generate a QR code? Then we can create another failure step and send an SMS to the user. The vehicle registration process failed due to this reason. But however, this earlier step has already been executed. The user's data or the vehicle data is already added to the vehicle table. So if we are to completely reset these states, we should remove that information. And AWS step function make that process easy. We can use patterns like Saga patterns that we can instruct the step function to clear out the previous states. So that will also be handled by AWS step function as an orchestration service. So if there's any failure for a particular user, we can get that request correlation ID and look at this workflow. And in that workflow, we will see, all right, something has gone wrong in creating the QR code. And then we can further observe it. What input has it received from the previous step and what was the error? All these things are visible to you. So error handling is really easy when we have a workflow orchestration service like step function added to our application. Now one might be wondering, are we able to use this EventBridge again to handle these steps? For example, when we get this vehicle matched event added to the EventBridge, we will create another rule and we can invoke this particular Lambda function. In the event rule, we can particularly say, check if the request is failed. If so, invoke this Lambda function. We can create another rule. That rule will check whether the request from the RMV system is successful. If so, we can send that events to this vehicle registration lambda. And once the vehicle registration lambda added that information to the vehicle table, that lambda can send another event to the event bridge, vehicle data saved. And again, we can have another rule listening to that event, and all these matching event will be sent to this create QR code lambda. You get the idea, right? We can use event bridge and we can completely take out this step function workflow orchestration part of it. And of course, we can do that. Then our system will be quite decoupled, and that would be a good thing. But however, there's a cost to it. The cost is mainly about troubleshooting for errors as well as this application getting very complex. Complex as in, if there's a newcomer to your team, he will have a very hard time understanding these flows. But when we have a step function express workflow, we can see how one step calling the other step, what are the retry steps as well, and how the errors are being handled. And all this information is graphically available for him or her. And the troubleshooting is also quite easy. And hey, can we add this part? Like, the calling this external system through SQS into this step function express workflow. By the way, I just saw there's a typo here. It should be step function express workflow. Well, unfortunately, we can't use express workflow for that. We have to use step function standard workflow because standard workflow supports asynchronous requests. But I would avoid using standard workflow here because standard workflows are expensive. In standard workflow, you are being charged for the state transitions. One of the state transitions would be registering your vehicle information and after that calling this QR code lambda and then send the success notifier and so on. And you will be charged $25 per million state transitions. But one of these execution will contain many state transitions. So ultimately, when you run your application in scale, you will probably see the standard workflows are expensive. But on the other hand, express workflows do not charge you by the state transitions. It will charge you by the execution time, the same pricing model that you have with Lambda. And on the other hand, we can invoke many express workflows in parallel. It's highly scalable. I think we can invoke about 100,000 express workflows in parallel. But the limitations are we can't use this type of asynchronous workflows attached to our workflow, as well as there's a 5-minute duration limit. So that's why we handle our asynchronous flow through EventBridge directly calling SQS queue and the rest of the steps through Express workflow. Because most of these events are synchronous. Because these events are synchronous. Registering a vehicle in vehicle table, adding the QR code image into S3 and saving that S3 URL in user table are synchronous. And DynamoDB S3 and this can absorb a lot of traffic. So we can call them synchronously. So we usually call this pattern the orchestration pattern. And if you are to use, let's imagine EventBridge to handle all of these events in a very loosely coupled manner using rules and so on, and that is called choreography pattern. So here we use both choreography pattern as well as orchestration pattern. So at the end of our workflow, the users will receive an SMS that their QR code is ready with a link to the login page. So in the next episode, let's talk about our login architecture, as well as I will also discuss about how can we add observability into our application architecture. Because as you can see, these type of serverless architectures are using so many services. So if we want to understand at what point do we see bottlenecks in our application and at what points do we have errors, The best way is to add good observability into your architecture. In order to add observability, you can use services like AWS X-Ray, and also you can easily use some third-party services like Lumigo that will help you to monitor and debug distributed application. A similar tool would be Thundra. And these type of third-party tools and inbuilt services like AWS X-Ray really helps you to see how your system works, where are the bottlenecks and so on. By the way, these guys are not sponsoring this video, but I've used them in my previous projects and they work really well. So let's discuss observability in the next episode and the user login part of it, as well as we'll discuss some of the other patterns that we can further use to improve the resiliency of this application architecture, such as how can we use circuit breaker pattern if required, and also how can we achieve idempotency in our application architectures. And also, if you guys have any questions, make sure you will add it to the comments. We can discuss those as well. So thanks for watching, guys. I'll see you soon.